Welcome to this presentation on accelerating productivity with Java 17, GraalVM, and Micronaut. My name is Graham Roche, and I am an architect at Oracle Labs, and I'll be taking you through these great technologies. So on the agenda for today, we'll look at an introduction to Micronaut, we'll do an introduction to GraalVM, we'll talk about Java 17 and how the features within it really improve the Micronaut experience, and we'll do lots of demos. So in terms of an introduction to Micronaut, Micronaut is a relatively new framework for the Java virtual machine that focuses primarily on the serverless and microservices space. However, you can use it to build any type of application. So it's really a complete application framework for any type of app, as long as it has a static void main. And it provides dependency injection and configuration management, aspect-oriented programming, and so on and so forth in a very different manner to traditional frameworks by essentially plugging into the Java compiler using annotation processors and pre-computing at compilation time the framework infrastructure of your application. This provides for a lot of additional efficiencies in terms of performance and memory consumption. And in addition to that, it has an HTTP client server based on the Netty toolkit, which means it's great for both non-blocking reactive applications as well as imperative applications. Really, it's both imperative and reactive, and really suits whatever style that you wish to use. You can find out more at micronaut.io, and do start the GitHub repository and follow us online. In terms of GraalVM is a new virtual machine out of Oracle Labs that is able to increase application throughput from 20 to 30% and reduce latency. It's also able to compile applications into self-contained native binaries using the native image tool, which is really awesome for a lot of different use cases, from cloud deployments with serverless and microservices to, for example, command line applications that are run natively on the architecture they were designed for. And in addition to that, it also has the Truffle language framework, which allows you to allows multiple different languages to seamlessly interoperate. And there are implementations for JavaScript, Ruby, Python, so forth, all built on top of Truffle and GraalVM. But in terms of JDK 17 support, it is on the way, but there are already developer builds available for you to try of GraalVM for JDK 17. To find out more, go to graalvm.org and do check out the demos repository. In terms of the relationship between Micronaut and GraalVM, they're essentially a match made in heaven. Micronaut essentially eliminates the need for reflection, runtime created proxies, runtime bytecode generation, and dynamic class loading completely, which makes it a lot easier for the native image tool to perform a closed world static analysis on your application and compute your application into a native image. And once it is in a native image, startup time with Micronaut and GraalVM is spectacular, dropping to the low milliseconds, orders of magnitude faster, and memory consumption becoming significantly smaller. You can find out more about native image at graalvm.org, and there are great demos of Micronaut plus GraalVM available in the GraalVM demos repository. So hello, Java 17. Java 17 is the latest LTS, that's long-term support release of the JDK, and it brings a lot of features that have been at various stages of preview in the previous releases into the LTS lifecycle. So you have great productivity features such as switch expressions, enhanced instance of text blocks, as well as awesome new language concepts like records to model value types and seal types, which allow how an interface or class controlling how an interface or class can be extended, as well as interesting features for the microservice space and general application performance space, such as class data sharing, which helps improve startup time even further. In addition to that, there are exciting preview incubator features that can kind of set the path for future releases, including things like pattern matching for switch, which we'll have a look at in this presentation, and things like the vector API, and particularly interesting to me is the foreign function and memory API, given Micronaut is based on Netty. Interesting to see where that goes. So to get started with JDK 17, GraalVM, and Micronaut is already JDK 17 ready. You need to make sure, if you're a Gradle user, that you use Gradle 7.2 or above. If you are looking for GraalVM developer builds with JDK 17, you can grab those from GitHub. Currently, there's no official release yet of GraalVM for JDK 17, but it's coming soon. In the meantime, grab those developer builds to use JDK 17 and GraalVM together, including the native image tool. So in terms of the features of JDK 17 that are great for Micronaut applications, records are great for modeling things like immutable configuration, representing database entities, data transfer objects, and so on and so forth, while sealed classes are great for library authors and API authors. And switched expressions really improve code expressions and code clarity, while CDS is good for startup, for JIT applications, and GraalVM native. But if you're looking for the ultimate in startup, do check out GraalVM native image, which is even better for native applications. Okay, so let's get started with the demo then. So in this demo, I'm going to be demonstrating using GraalVM, Micronaut and JDK 17 together to build a simple Micronaut application that does database access. And we're going to go through looking at some of the interesting features of JDK 17, including records, which and sealed type. I have a Micronaut application here, which has an application class and a test. And what I'm going to do is I'm going to create a new Java class that is going to be an interface called entity. And this is going to be like the super interface for all entities in my database application. And what I'm going to do to this is I'm going to make it a sealed interface that has a single generic argument that is the ID type, which I'll expose via a method. Now you can immediately see by making this a sealed interface, I have a compilation error. It's because sealed classes must have subclasses. So a sealed class must have at least a single subclass. This is important part of their design. So I need to define at least a single subclass, which I'm going to do using a record. So I'm going to define an author record, which is going to model the author table in my database application. And I'm going to have an ID that is long and a name of the author. And so this is my author record. And what I'm going to do is I'm going to make it implement my entity sealed interface, supplying long as the database type, ID type. You can see now that I have a compilation error. And that's because with sealed interfaces, you cannot directly extend a sealed interface. You actually have to declare which classes or interfaces are allowed to extend it with the permits keyword. So I can say permits author, and then that will now compile. So you actually have to declare in the sealed interface what is permitted to extend, in this case, author, the interface, which allows controlled extension of the API. What I can do now is make this a mapped entity in Micronaut data, and I can add to the ID a few annotations to make it generated from the database and indicate that it's the database ID and that it starts off as null. So those are a few Micronaut data annotations that allow me to control that the ID property is the database ID. And with that, we've done my author record. Pretty simple. And look how concise and nice it is with records. So what I'm going to do now, I'm going to create another record to model another entity called book in the book table. And once again, we're going to make it a record, and we can make it a mapped entity that maps to a particular database table called book, and we give it an ID, we give it a title of the book, and maybe a number of pages, and the author association, because each book has an author in this system. So there we go. There is my book record with the 4 record components. And again, look how syntactically concise records make this kind of thing. So once again, to the ID, we can make it a generated value that starts off as null using that nullable. And then we can make it implement that entity interface as well. Now, when I do that, once again, this will fail to compile, as you can see, because book is not allowed in the sealed hierarchy. So we can jump over to entity and make sure it's permitted. So now we know that author and book are permitted to extend this interface, which is pretty cool, that you can control. And now, a new entity can be added without specifically declaring it as in the sealed type. And the whole ability for records, which are implicitly final, to implement sealed types implicitly works really well. So what I'm going to do now is create a author repository interface with Micronaut data. Micronaut data allows the definition of repository interfaces that you annotate with @JDBC repository, adding a dialect. And what you can do is you can extend from the CRUD repository parent interface, which is part of Micronaut data, and supply the entity type and the ID type. CRUD repository is an interface that allows CRUD operations to be performed. So it has methods to create, read, update, and delete entities using JDBC and underneath the covers. And this is a great fit for records because JDBC is stateless. So I'm going to create a book repository that does the same thing for the book entity, extending from CRUD repository with book and long, and annotated with @JDBC repository and a dialect of H2. So there we have my two repositories that are going to allow me to perform some CRUD operations. So I'm going to jump over to my application class here, and I'm actually going to dependency inject them into my application class using constructor dependency injection. So making these both final, I'm going to add them as constructor parameters to this type. And because it's a singleton defined with Jakarta.inject, it will be dependency injected. I'm going to add an event listener called startup that listens for the startup event of Micronaut. And I'm going to make it transactional as well. And what I'm going to do in here is I'm going to use my author repository to save a new author. So I'm going to save a new author, and let's save Stephen King, for example. And probably I need to define a null ID initially, and we're going to pass it in. And why is this failing to compile? So look, not within its bounds. It looks like I made a mistake. Yes, in fact, I've supplied book to the author repository. It should be author. Thank goodness for type safety and generics. So let's save that, and let's assign it to a return value. Now, it's important to assign it to return value because the author that you pass in doesn't have an ID, and Micronaut data will use a copy constructor approach to take the null ID and return a new instance with the ID assigned. So so you'll see if we output this, for example, to using system out to output the ID, the returned object has the database ID assigned, which we can then use to save our different book instances using this author, using the resulting ID. So what I can do is take the book repository, call save all, and save a couple of books. So I'm going to save a book. And again, we can pass null for the ID, and we can maybe save the stand, which was a really long book, so 1,000 pages, and pass in our saved author. And we can save the Shining, and that was a shorter book of maybe 500 pages. And we can save those two books, add the semicolon in the end here. And basically that is my application. So I can jump over to my test. And what I'm going to do is I'm going to inject into my test, and this is a test that's annotated with Micronaut test, so I can dependency inject author repository into it. And I'm going to add an assertion in here that asserts that when my application runs, the number of books in the database is 1. And this will just assert that startup logic is invoked. And let's run it and have a look to see what happens. So we're going to run the test. And as you can see, the ID gets assigned. There it is, the ID gets assigned, and the test passes. So there's one author in the database. The ID got assigned from the database insert, and my assertion asserts that was successful by doing a count on all the available authors. Now, the cool thing about Micronaut data, JDBC, and records is that they support all the features, for example, validation. So I can add a not blank on the title. I can make sure that the page is positive. I can add other validation rules here. For example, on the author type, maybe I can say that it should not be null. So I can add all my normal validation rules to the record, and the same thing with the author type. So I can annotate the name can't be blank, for example. And if I violate any of these rules, if I jump across here and maybe I pass in negative number of pages, and I try and run this as a test, you will see that it will now fail. My application will fail to start up, in fact, because pages must be greater than 0. So Micronaut Data's validation rules is kicking in for the records. So I'm just going to correct that. And with these great syntactically shorter records, you can define validation rules, you can define all, and it's all much more concise and elegant with Micronaut Data and JDK 17 records. So really cool how records simplify all of this and make it easy to write these kinds of applications. So let's just run my application again to make sure that the test is passing. Now this sealed interface has an explicit permits that permits author and book. What I'm going to do now is I'm going to create another sealed interface, and we're going to call it Bookstore API. And I want to demonstrate another aspect of sealed interfaces. So once again, this is a sealed interface, and you can see it doesn't compile because there's no subclasses. But what you can do is you can define an inner class that implements the interface. Now, if it's a class, it needs to be final. So in case I'm defining a controller that implements the API, so I have to make the controller final to implement the sealed interface. Otherwise, I can't implement it. But as you can see, sealed interfaces can define inner classes without a permits block. So I'm going to define a method in my sealed interface which allows me to retrieve a description of a particular type. So for type of thing, so it's going to be describe, and then it's going to take the type of thing we want to describe and the ID that we want to describe, ID of the thing we want to describe, something in the system that we want to describe. And I'm going to implement this in my controller. So there we go. And I'm going to annotate this at controller in Micronaut to map it to an HTTP endpoint. And then I'm going to inject into here my book repository, and I'm going to inject my author repository into the controller, like so. And we're going to add those as constructor parameters and dependency inject them using Micronaut's dependency injection capability. So I've defined a controller that maps this to the endpoint. I'm injecting book and author repository. And now I'm going to come down to my describe. I'm going to take the type, which is going to be bound from a URI variable in the URI. And I'm going to use that type to select the appropriate repository to look up the object with. And I'm going to do that with a switch expression. So let's have a go at doing this. I'm going to define use CRUD repository, and I'm going to use some generics here. I expect the CRUD repository to extend from entity and have a type of ID. And here I'm going to use a switch expression. So I'm going to say type.toLowercase, and I'm just going to say case. In the case where it's a book, then I'm going to assign this to book repository. So I'm going to use the CRUD report. In the case it's an author, I'm going to assign this to author repository. So unlike regular switch statements, and I can fall back to using null. Unlike regular switch statements, we can actually assign this to a variable because it's a full-on expression, right? So we can take the type and choose the correct repository to assign to a local CRUD repository variable pretty simply. And if it's null, we can do nothing. And when you return null from Micronaut controller, it results in a 404. So by default, we'll just 404. Otherwise, we can use this repository to try and look up the entity by ID or result in null. So let's look up the entity. So now I should have an entity object, all null if none exists from that entity argument. And what we can do here is start doing now I could, for example, do a null check and then do some casts and so forth. But what I'm going to demonstrate here is enhanced instance of. So I'm going to say instance of book B. Now, as you can see, you can use a variable name to the right of the instance of expression, And that allows you to eliminate the cast in subsequent statements. So I can just call b.title instead of having to cast down to book. And the same thing if I do instance of author A, I can just call a.name. Now this is really cool and really improves the expressivity of Java a lot, because you eliminate a whole bunch of casts. The switch expression is a whole bunch better than using a map, and I don't have to cast down to book or cast down to author, and I can just use my controller to describe this endpoint. Now, the bookstore, as you can see, this controller implements the bookstore API. So what I'm going to do now is going to be really interesting. I'm going to define another interface which is non-sealed, and this is a non-sealed interface called book client that extends from bookstore API. So you can actually unseal a sealed interface with the non-sealed keyword, and this is, I believe, the first keyword with a hyphen in it in the Java language. So I'm going to make a non-sealed interface, and in my test here, I'm going to define a test client called test bookstore client that extends from the bookstore client interface. There we go. As you can see, I'm going to annotate it with @client. Now, this is going to use Micronaut's declarative client ability to automatically implement an HTTP client for me. Now, the important thing here is I can extend from book client, because it's non-sealed, but I cannot directly extend from bookstore API because it's still sealed. So this allows me to say that, the users of my API have to identify themselves as clients. So let's see how this works. I'm going to use my author repository here to find a particular author. I'm just going to find them all and return the first one just for the simplification of this demo. I'm going to find an author, and then I'm going to inject my book client, which is implemented by my declarative client here, into my test. And I'm going to call on this client in the body of this test. I'm going to say client.describe author, and I'm going to as the kind of type and ID. And I expect what I'll get back here is the name of the author. So let's write an assertion for that. I expect the name of the author to be Stephen King, and that to be the result. And this is going to make an HTTP call to my controller. This is a full integration test, and it's going to hit that logic that I've written in my other application. And maybe we can try out looking up a book in a minute. So I'm going to add a book repository here. And let's run this and see what happens. So I'm going to run it, and let's see what happens. So, and the test passes. So it's calling describe with my HTTP client, which is making an HTTP request to my local server, and it's hitting my book controller here, which is looking up the appropriate CRUD repository using a switch expression, and then using an enhanced instance of to return the appropriate description, either the title of the book or the name of the author, using instance of. I think that's really nice simplification for creating these kind of dynamic systems. I think that's really cool. Okay, so let's see how we can make this even better though with a switch expression. So what you can do is I can actually switch on the entity, and what you can say is, using a switch expression, I can say, and this is using pattern matching. This is using a brand new feature of the JDK, which is in preview, called pattern matching. So I'm going to switch on the entity, and in the case of it being a book, I'm going to return the name. In the case of it being an author, I'm going to return the name, sorry. Otherwise, I'm going to return null. And you can actually return this directly. And look at this simplification this is going to enable with JDK, future versions of the JDK. So this is a switch expression with pattern matching. So I actually pass in the entity, and it looks like I need to enable preview features here. My application didn't compile. So I need to go over to my build.gradle and make a little modification to my build here. Seems I've enabled preview for compiled Java, but not for compiling my tests. So I need to enable preview since I'm using a preview feature, which is pattern matching for switch. So I'm going to, let's try that again. You can see, now it's working, I think. Yeah. So you can see the IDE level support is not there yet. IDEs are not ready for pattern matching with switch, but you can pass in the entity directly. The only thing here is this may actually produce a null pointer exception. So you probably want to add a check here that making sure that the entity is not null before passing it into the switch expression. So we can do that. And that'll resolve that issue. But as you can see, you can switch directly on the entity and then use pattern matching in the case of to invoke the right method using switch expressions, which is really, really nice syntactically and a lot shorter than the nested instance solves. And it works really well and it's really readable. So I think that's pretty cool. Now, what I'm going to do now is demonstrate how that can be extended. So I'm going to add an enabled field to my book entity, just in case, for example, you wanted to implement soft delete. Now, that actually caused this compilation error, and I want to demonstrate another feature of records, which is they can have secondary constructors. So I'm actually going to add a secondary constructor to my book record here, which has the title of the book, the number of pages, and the author record components. And what I'm going to do is I'm going to invoke the default constructor, passing in null for the ID, type, pages, and author, and enabling by default. So when you create a new book, it's enabled by default when I save it. So in the enabled component is going to allow me to enable and disable books in this hypothetical system. So let's just get rid of those nulls so I can invoke my secondary constructor and fix those compilation errors. So now if I could modify my CRUD operations to disable a book, for example, and then in my API, what I can do is check for book is a book, case is book, and I can do and be enabled. So you can actually define additional method calls and logic inside your pattern matching statements, and that will only return enabled books. And I think that is a really cool and expressive feature with pattern matching for Switch, which is a preview feature of JDK 17. I think that's really cool. And that's it for that part of the demo. So what I'm going to demo next is using class data sharing. So I'm going to assemble up my application into a runnable jar file using GradleW assemble. This is a Gradle build, but if you're using Maven, you could use Maven W. And this is going to build a kind of jar my application into a jar file, which I can run with Java. And I need to enable the enable preview flag because I'm using preview features. And what I'm going to do is I'm going to add a parameter called archive class names at exit. And I'm going to just give a name of a class name called class data. And I'm going to use the jar flag to run my application. So I'm going to run my application inside terminal here. And this is going to start up Micronaut. And as you can see, it takes around 2 seconds, which was as expected. And then when I actually exit this application, you'll see that it's going to write out what's called a class data archive. Now the benefit of this, you can see it there, it's called class data. It's just the name I gave it. The benefit of this is I can run this again using a different flag to Java. I used archive classes on exit the first time. And the second time I run it, I can use shared archive file and pass that file name that I used before. And now when I run the application, you see the start time is 660 milliseconds, 670 milliseconds, and 668. So that's a big improvement over the 2 milliseconds that was there before. Just to kind of demonstrate that, I'm going to run it without any flags and see what happens. And you can see that if I run it without any flags, it's like 1.3 seconds. So there was some overhead to saving the archive at the beginning. But you see there's still a big jump, still a 50% improvement using class data sharing for JIT applications, which can be an important factor if you're building microservices. And that is the demo of Micronaut GraalVM and JDK 17. Um, so uh, um, to get started with JDK 17, GraalVM, and Micronaut framework, you can grab those developer builds um, at the GitHub GraalVM releases page. You can head over to Micronaut launch and generate a new project today with JDK 17. And you can open it with your favorite IDE and then jump over to read documentation. There's great docs in Micronaut on GraalVM and JDK 17, and you can start developing today. So in summary then, version 3 of the Micronaut framework contains awesome support for JDK 17. Records reduce complexity, promote immutability, and lead to more concise code. Sealed classes make it easier to control encapsulation and how your application can be extended. Switch expressions, pattern matching, text blocks increase expressiveness and readability of your application. And class data sharing provides a welcome boost to startup time. But if you want the ultimate in startup time, you should check out GraalVM native image and enjoy Micronaut GraalVM and JDK 17. Thank you very much for your time, and I hope you enjoyed this presentation.